My name's Paul Trubridge. I'm head of products at Quartus. I know some of you know Quartus. I don't know exactly how many of you. So what I'd like to do today is really give you an introduction to what we do and how we fit into the Lime ecosystem. So introduction to Quartus. We've been a long-term partner of Lime. We've worked with them from the start on the SDR program. We basically provide software for core networks, or with core network functionality. So that's for 2G, 3G, and 4G. And what's special about our product is that it's, or our software, is that it's collapsed down into a very efficient executable that can run where normally a core network wouldn't run. So you'd normally host a core network for these technologies in a central data center, and it would serve thousands of edge-based radio nodes. What we do is we're able to take our software and push it closer to the edge of the network, and that can bring some quite interesting architectures, topologies, and also lead to some quite different use cases. Probably the most extreme use case being a complete network in a box. So the radio and all the core network functionality actually running down on the same chip in the extreme, where you just get into, or you get IP straight out the back of the base station. So our focus is on edge-based core network functionality. We're deployed all over the world. We've been going for sort of 8 years or so, with about 40 staff based in Camberley, and we're sort of largely deployed in private cellular networks today, and more sort of branching out into the ability to enable a carrier to deploy remote network extensions, maybe over satellite connections, being able to provide the resilience in the network by distributing the core network functions so that you can cope with sort of less than ideal backhaul. In enterprise networks with edge computing techniques, so if you follow Etsy and their mobile edge computing working groups, we're active in that, and we have a product that allows you to push user plane elements out into the edge of the network, into the enterprises, and provide, well, what's really sort of fixed mobile convergence, where you can access local resources from your cellular handset. Military and tactical sort of deployments with sort of public safety, they go hand in hand. Sort of network in a box is very typical for those kind of deployments, where you want to take a single unit as a first responder, get to the incident, put it down, and then you have a bubble of coverage. And we do features that allow you to then, where there's connectivity, reach back into the mobile carrier's network to create a network extension. But while there's no connection, you still maintain that bubble of coverage for your first responders to communicate together. Other applications, sort of government solutions with special functionality that we've developed, and what's becoming sort of more and more mainstream, I guess, is IoT, so Internet of Things. Having a different class of core network for carrying sort of Internet of Things data back into a mobile carrier's core, or maybe keeping that data privately within the enterprise. So a lot of enterprises regard that kind of machine-to-machine data is very sensitive. They don't want it going outside of their own network. So by providing a local core function within the enterprise, you can keep that data separate while still giving connectivity for the mobile cellular users back into the carrier's network. So with respect to Lime, we have sort of 3 products that are compatible with the Lime SDR platform. We have Ecx Core, Ecx Tactical, and something we call Pocket EPC. Ecx Core is really the sort of flagship product that provides full 2G, 3G, 4G core network functionality, as well as an IMS component for enabling connectivity to a PBX, for example, and running VoLTE, so maybe a private VoLTE network over the air. So we have a demonstration of that later on this afternoon. It's highly scalable. You can run it as a single instance down on the Lime SDR, or you can run it in the cloud. And we've done lots of 5G developments where, with that product, where we've disaggregated the functions, the control and user plane functions in the network, so that we can separate those. So have control and user plane separation and scale the network in a cloud environment, for example. It has all the interconnects for providing an interface into the mobile carrier's network, whether you're using it as an MVNO or whether you're using it as a network extension and you need interconnects back through over a satellite connection, for example. It also has sort of billing capabilities, so billing interfaces. So that's the product that it includes all of the sort of features that a mobile carrier may want to use, whether they're deploying the core centrally or whether they're deploying the core right out on the edge of the network. In the middle here, we've got Ecx Tactical, which is really aimed at public safety and military markets. It's all about getting the core network down on the same box as the radio, so it's perfect for the Lime SDR, for example. Very small footprint. I think it's a 40 megabyte binary that runs down. We can run it on a single ARM core. So we've had it so that we've hosted that product on a single chip that's running both the eNode B stack and the EPC all on a single piece of silicon. We've incorporated some feature extensions into that product, which are aimed at the military and public safety market. And if you're interested in that, we've not necessarily included it as a package for the hackathon. But if you're interested in that kind of application, then come and talk to us, and we'll help you get started with that one. Finally, we've got the Pocket EPC, which is what we're launching on the Ubuntu App Store shortly. Before then, it's available outside the App Store, and that's really aimed at sort of labs and individuals who are doing research using the Lime SDR. So it comes as a snap, which is the Ubuntu sort of container for packaging apps. So it's provided as an app off the App Store that runs down on a snap on the SDR, and it's had a lot of the sort of, for example, it's not got 2G, 3G capabilities. It's entirely focused on 4G. A lot of the functionality has been stripped out so that we've made a nice low-cost piece of software for for development purposes, really. This provides you an idea of the functionality we have in ECX Core. So we have all of the 2G, 3G core network building blocks. We have some interfaces into to operation and management systems. So basically, CLI. There's also some SOAP. There's a SOAP interface. We support SNMP as well for network management. It includes PCRF. I don't know how much you know about 4G core networks, but basically the PCRF sets up the policies for handling bearers across the radio. And one example of that is where if you're running VoLTE, for example, you want to set up a dedicated bearer over the radio, which is highest quality, lowest latency to establish, and a guaranteed bit rate for the highest quality voice call. And the PCRF interacts with the IMS system. So we have some IMS capability that when you make a VoLTE call, maybe a private VoLTE call over our system between two handsets connected, it will set up a dedicated bearer for that VoLTE call. There's also a SOAP interface directly into the PCRF that allows you to trigger dedicated bearers based on your own events. So if you have, if the application you were developing would take advantage of dedicated bearers, and you wanted to, on an event where you were passing certain data over the radio, you wanted to sort of manually trigger or from your application trigger a dedicated bearer, there's a SOAP interface into that PCRF. There's SIP interface out to a PBX or any kind of SIP client, and roaming interfaces, as well as billing capabilities. So the Pocket EPC and ECX Core both support an embedded HSS, which is where the user and SIM data resides. And you can program that yourself, or it comes pre-programmed with on the Pocket EPC. It comes pre-programmed with all of the SIMs that we provide, as private SIMs. So looking at a few typical architectures that we get deployed in, we support. I think I've got 3 examples here. The classic centralized architecture, where you have the radios on the edge and you have a centralized core network. Now, whether that's actually running as an MNO core, or whether it's running as a private core network onto a private LAN with some roaming interfaces into the MNO, it's very similar. Basically, the thing here is that we're centralizing the core, and you might be running it on a large server with sort of separated functions all running in their own VMs, for example. The other sort of more common for us architecture is a distributed architecture, where we push the core network functions out onto the edge of the network, whether they're running on a small sort of single board computer, or whether they're running on the radio itself. It doesn't matter. But the point here is that we don't have a centralized core. We have lots of small instances of core out in the network. And whether they're feeding a single eNode B or a cluster of eNode Bs, they're pushing that functionality out onto the edge. And they make it look more like a fixed network from a topology point of view, without the need for a sort of centralized core. But you still get mobility. We do something called inter-Mme handover, where we hand over between core networks. So you still get the same level of sort of mobility function for the end users, but you've pushed the core all the way out to the edge. And when you push the core out onto the edge, it reduces the complexity of the network. It makes it look more like a Wi-Fi deployment. And what we try to balance is the fact that we're integrated with a mobile network operator, but we're generally managed by an enterprise using IT skilled staff. So we have a very simple management interface into the core. Normally, you basically put it there, and you don't need to do anything with it. You don't need a network operations center to run a network like this. You run it in the same way as you do a Wi-Fi network today. The other advantage is that it's a lot more resilient when the fact that you distribute these functions adds resilience anyway, because you're not reliant on a centralized core network. So if you're addressing sort of quite remote sites, then having the ability to have the core network functionalities out on those remote sites, all of the sort of control plane messaging going on locally rather than being backhauled backwards and forwards across a satellite link, for example, adds some advantage. And efficiency as well. S1 is tunneled from the eNode Bs. It carries an overhead. That tunnel carries an overhead. So again, if you're backhaul constrained, then being able to backhaul IP rather than backhauling tunneled S1 is an advantage. We also support a hybrid architecture where we keep the control plane functions central on the network, and we push user plane functions out onto the edge of the network. And so with the serving gateway, we're able to take the user plane side of that, deploy it locally, so with some routing capability that allows you to break out from the break out onto a local LAN rather than going back through a centralized core. So in this case, we push an SGW user plane element out onto here. The users that connect to via this core, via these small cells, get access that's controlled by the enterprise onto their local network. For example, IoT, where you want to keep that local, but you want to be able to have handsets go back through an M&O core or a central core, then we're able to take the IoT traffic and terminate that locally while routing everything else via the central nodes. So this is really a software-defined networking implementation of a core network where you're distributing user plane functions out onto the edge of the network. Ecx Mech is really sort of pioneering this concept of local breakout, but adding this sort of app environment where you can take advantage of local breakout with particular apps. So I don't know, let's say you want to interface into a Netflix CDN, and all you do is you pull down an app onto the appliance that sits out on the edge of the network that enables the users to access a Netflix CDN directly rather than going back through the core. So you're not worried. You're not then hampered by the transport bandwidth and latency build-up back through a sort of more traditional core. We did a proof of concept for Ecx for healthcare, and the local breakout capabilities gave a deployment in a hospital of a small cell deployment within a hospital. As you walk into the hospital, you connect into that small cell network. As you then register from being a member of the public to being a patient, you're given limited you're given limited access to local services, maybe IP streamed hospital radio, if you want to listen to that. If you're a member of staff, you get a different level of access to the local services, but it's all under the fact that the control of, or the access control to the local services is under local control. You don't have to request from the M&O access to different types of services over the cellular network. It's all under the hospital control. And one example was when the hospital goes into a critical situation. Maybe there's a big accident somewhere, and they need to ensure that the LTE resources are given to the right people, i.e. the doctors. They're able to, in the fact that we have local control here, they're able to set a critical alert status, and that reprioritizes the LTE resources that are made available. So the staff get access, the public just get thrown back up onto the macro network, the patients maybe get SMS capabilities, but the idea there is that you don't, again, have to call the M&O to change the status of your network, or your local network. Another example using for IoT, this is something we deployed recently in Europe. It's a slightly simpler example or a simpler way of implementing separation between the IoT traffic and the cellular traffic. It's simpler than using local breakout with mobile edge computing. And what we did with a factory is we put a private core in the factory, running small cells, so it could be the Lime small cells distributed around the factory, and they were transmitting two separate PLMNs and network IDs. One was the M&O carrier's ID, which the handsets connected to as usual, and another one was a private PLMN, which the IoT devices, the monitoring devices in the factory connected to, and they were terminated through this private core straight out onto their private network. So it basically provided them with a cellular IoT layer within their network and an improved coverage for the mobile users. So the operator was incentivized to put in small cells into this location for two reasons: to keep the enterprise on board for IoT, and also to improve the quality and coverage of the network for their customers who work in the factory. So the base functionality, we're at risk of repeating myself from the diagram we had earlier. All of the 4G EPC functions and 3G and 2G plus IMS. This is Ecx Core we're talking about. So it's an IMS. It's a sort of light implementation of IMS. So again, Ramesh can show you what that does. We've got a demo that attempts to show you all the sort of capability of that IMS implementation. Roaming interfaces for 4G and 3G. There's some radius sort of authentication and accounting capabilities in the software as well. We also have a AAA function that allows us to sort of interconnect with Wi-Fi, make the connection between a Wi-Fi AAA and the HSS, so that you can authenticate Wi-Fi off of the SIM that's in the handset. For a sort of centralized core, it's important to to support some kind of redundancy or high availability because of the vulnerabilities of a central core. It may not necessarily, I mean, it's not necessarily directly relevant here unless you're using a split architecture where you're running some of the functionality on the line SDR and some of it centrally. So what we can support is a high availability mode for the centralized elements where we store the steady state information and allow you to fall back to a sort of standby system, maybe a geographically separated standby system or just one that's on a separate server in the same location. So final slide. For the hackathon, we're offering you access to the Pocket EPC and Ecx Core. As I said earlier, Pocket EPC is £150 per instance, and that's really aimed at individual developers. And it's supported via an online sort of wiki, which acts as an information portal, and there's a forum a user forum which our support people will check regularly and help out where necessary if you need to post questions. And of course, the idea there is that the community also helps one another out where it can. Ecx Core is really aimed at a corporate R&D environment. We've set it at £3,000 per instance with a support fee for a year of £1,500. I mean, the reason we're doing this is really to cover our support costs, where you'd be motivated to use Ecx Core if you needed to use the more advanced features, or you wanted to use the more advanced features, which generally requires a bit of support from our side and help. So we're sort of aiming that at we hope corporates that would be happy to pay that kind of fee. And both of them are provided with SIM cards. We say 2. I mean, if you need more than 2, I'm sure we can stretch to that. So, as I say, Ramesh will give a couple of demos. We've got a Pocket EPC demo and also an Ecx Core with IMS, so running a Vultee demo later with that. If you're interested, he's got SIM cards that we can provide today, and then you just need to contact me about getting connection to the license server for running these things up on your platforms.